Right. Good morning from Taipei, Taiwan. It's Chris Camacho, President CEO of Greater Phoenix Economic Council. Excited to welcome everyone to this important special webinar that's focusing on the new photon economy. We have some top rate speakers today who you'll hear from in a moment. There's roughly, I believe, 350 folks joining us today from all over the country and around the world for this important topic. So before we dive right in, I know we're a few moments behind, so we're going to get caught right up. You will see housekeeping items for today. We plan to run for approximately 60 minutes. We will have all of the audience members muted without video sharing capabilities, but this webinar will be recorded, and you may submit questions to the Q&A function at the bottom of your screen, and I will receive those questions, and I'll do my best to weave those in at the end of the conversation today. So without further ado, I wanted to certainly reference the importance of this particular topic. We've seen climate effects around the world that we'll talk about here in a moment. And naturally, with IRA and the IIJA from the federal government, we have unprecedented funding that's supporting the advancement of these novel technologies. And throughout the speakers today, we have first Dr. Michael Crow from Arizona State University, Bill Gross from Idea Lab, and Jonas Lee from Carbon Capture Incorporated. Those three speakers have a very unique level of understanding, not only of climate tech and climate effects, but certainly how to advance a strategic plan on the economy. All of that said, over the last decade, we've seen Greater Phoenix evolve from being one of the most real estate dependent economies historically to one of the most advanced and well-positioned and dynamic economies in today's world. As I'm sitting here in Taiwan, I can tell you that the view of the United States, and specifically Arizona, we have one of the hottest hands in regards to companies wanting to make investments in our state. And that's in a number of technology sectors, from space to cybersecurity, from quantum computing to advanced electronics. All of those included are great feeders to what we're going to talk about today relative to the environment, carbon, sunlight, and all of the natural resources we have to harness. So with that said, I would love to first introduce Dr. Michael Crow. Many of you know Michael from his work at ASU for the past few decades. What an incredible leader and a thought leader, not only in our community, but nationally. And Michael, I'd love for you to impart us a few words as to how you view the photon economy evolution, and those key ingredients are going to be critical, albeit policy, strategy, innovation, integration, leadership, all of the aspects for us to become a tier one global market in the photon economy.
Yeah, well, thank you, Chris, and try to enjoy the food over there. You just have to look at it closely, and so the place that I would start is that it's really, you got to be careful not to be overly influenced by all the negative discussion and energy that's allowing media companies to sell advertising. They need as much negative energy as possible, as many sky is falling stories as you can possibly imagine, to get enough momentum of people to attend and watch their stuff and sell advertising. And so it turns out this is an unbelievable time to be alive, because human beings have passed a point scientifically and technologically where our understanding of nature is so significant. I don't say that with hubris. It's just, we understand things now that we didn't understand 500 years ago. We understand things now better than we didn't understand 50 years ago when we began to understand genetics. We understand things now 5 years ago that we didn't understand on advanced materials and quantum computing and quantum biology and quantum physics and all kinds of other things, which means then nature, which operates in an unbelievably high level of elegance, has for the first time in our history as a species allowed us to think about how to build an economy built on the way that nature's economy works. So nature's economy, at least on this planet, basically is derivative of unbelievably complicated crystals that operate in plants that allow water and carbon dioxide and sunlight to perform unbelievably sophisticated chemical processes that allow work to be accomplished, things to be grown, chemicals to be produced, DNA to be transferred, all the things that are going on. And so this idea of a photon or a new photonic economy is one in which we're at a point now where we have the means by understanding how to capture carbon, by understanding how photosynthesis works, by understanding the chemistry between water, carbon dioxide, and sunlight, to basically now say to ourselves that we can move into a photon-driven economy, which would allow us to produce electricity, which we need, food, chemicals, biosystems, bio-industrial systems, medicine. The capturing of carbon from the atmosphere will allow us to build a carbon economy. What we've learned here at ASU in the last 20 years in building what is now our Global Futures Laboratory, our new School of Sustainability, our School for the Future of Innovation and Society, our School for Complex Adaptive Systems, our School for the Future of the Oceans, all the things that we've been building, our new algae technology systems that we have, our new light-based energy systems, our advanced solar technologies, hydrogen technologies, carbon capture technologies that some of our folks have been working on, in addition to carbon capture, who's here with us today, carbon capture Inc. What we realize is that there is, for the first time in our history, an opportunity to build an industrial foundation around the way that nature works, as opposed to heating and beating and bending everything, digging old animals and old plants out of the earth and lighting them on fire in billions and billions of campfires and billions of oil burners, and making this then the basis of our energy system. Nothing wrong with the progress that we've made, in which all these fossil-based systems gave us, what we needed. But in a sense, you got to look at this as this was an older, cruder way. That's not actually the way that nature works. Nature doesn't work by collecting dead plants and burning them to produce heat, or plants don't work at anything other than room temperature at atomic scale. And so our notion is that Arizona is very well positioned in every possible way, intellectually, technologically, economically, politically, open-minded, open structure, open flow, open people, highly driven by innovation. We've been able to build a whole new university here and make things happen to basically be, one of, if not the central place for the emergence of a photon economy, a photon-driven economy. And by photons, that means everything from capturing the carbon in the atmosphere and using it for other things, to replicating photosynthesis, to, as I said, producing new chemicals, new foods, new industrial systems, new ways of doing things. Our university is built around the notion of trying to use interdisciplinary design and transdisciplinary structures to be able to basically produce the kind of know-how and systems and tools that are needed so that we can help lay down the foundation for an economy that should be better for ourselves economically, better for ourselves environmentally, better for ourselves in terms of intergenerational responsibility, in terms of laying down the foundation of how to help the planet to serve humans without humans destroying the basis of that service. And so all of that is a part of what we think is this unique opportunity. ASU has been working with others, including some on this call. A local carbon hub was just one as the first phase of demonstrating technology development going forward from the Department of Energy's air capture system that's out there. We're very excited about that. We've got all kinds of things that are happening. We think there's huge opportunities for investment. We're in an opportunity horizon, an arc of accelerated outcomes. We have investor-backed companies out of ASU in water capture, solar-powered water capture, cyanobacteria production of chemical feedstocks, algae-based systems, carbon capture-based systems, all kinds of things. And so we've got now this notion of multiple carbon capture technologies, including Carbon Capture Inc., all kinds of opportunities for us to move forward. And we think that this is it's hard to sort of describe this, because you've got to get your arms around the fact that the new economy, and I'm not talking about environmentalism, I'm talking about a whole new way to think about how to manage our relationship with the planet, but more important than that, how to use the assets of the planet, the atmospheric systems, the planetary systems, the solar systems, the solar inputs, the photonic inputs, how to use nature and all of its power and all of its elegance and all of its glory to build economic opportunity for us. What we've been doing at ASU is we've been finding ways to advance our own infrastructure. We have constructed a 30,000 student engineering school, eyes on the future of the workforce, including a school for sustainability engineering and the built environment engineering. We built a new global futures laboratory, which involves 700 faculty members, has more than $150 million a year of research projects, expenditures. We're involved in everything that you can imagine in planetary management, planetary systems, sustainability, advanced innovation, everything. We've made that happen. We've been working on expanding our R&D activities, expanding the way that our business school operates, the largest business school in the country, 20,000 students in business, 30,000 students in engineering, tens of thousands of other STEM majors. We've been expanding, let's say, in the photon economy, and you're trying to figure out how to produce more trained individuals in everything from advanced materials to biology to chemical engineering to carbon-based engineering systems to hydrogen capture systems, to, whatever it happens to be. We've built the tools for degree programs, the tools for training, a whole new workforce development activities, partnerships, facilities, all these things. And so, we've been changing who we are to really lay down the track for this new economy, this new photon economy. So we're very excited about that. And what we really need here, and this is a hard thing in Arizona, is we need risk-taking capital investment to step up and help new ideas to move forward, new companies to move forward, new technologies to move forward. This is the opportunity. So here we have in Arizona then a world-class research environment, a world-class training environment, a world-class educational environment. We're working, we're now the largest producer of engineers in the United States. We're expanding to deal with hundreds of thousands of training situations with individuals so that you can train a workforce to move in new directions. We've got new companies coming to Arizona, new companies making investments of their technology in Arizona. We've got all these things happening. So what we need is capital partners, capital investors, risk takers, investors in both the technologies that we're spinning out of the university, the systems we're spinning out of the universities, and others that are coming in. And so the opportunity is huge. I mean, it's huge in every possible way. We are accelerating everything that we've got going on. We have a hydrogen hub that we're a part of. That's low billions of dollars of funding. We were just funded for a new technology to produce advanced metals like and alloys like steel and other things without using non-electric derived heat to make these things happen. So we've got all kinds of new ways, new technologies, new systems. We were just funded $90 million by the National Science Foundation as 1/2 of the cost of the building of the most advanced X-ray laser ever built by humans, which will allow us to basically understand photosynthesis to the extent that we can then reproduce photosynthetic designs and photosynthetic systems, from which then we need carbon dioxide as an asset, water as an asset, and sunlight as an asset. And so to make all these things work, we need to take advantage of this particular moment and find a way to help this economic opportunity to be accelerated here in Arizona. And what I can say, and I'll end with my comments on this, is that we have risked, make no mistake about it, billions of dollars, hiring people, building facilities, building laboratories, building equipment, building advanced learning systems to make all this happen. And the underpinning of knowledge creation, technology support, learning support, and educational support is now in place for a new photon-driven economy. So here in Arizona. So what we need is more, basically for this to work, we need accelerated activity by more actors. We need accelerated activity by more entities. We need more risk-taking capitalists to be here to try to make this new photon economy work. So Chris, maybe I'll stop there and maybe we can deal with questions later after the other presentations.
Thank you, Michael. And maybe just one expansion since I have the question in my head, and maybe others might have the same question, is there's been a lot of discussion about the land down at ASU Poly, and specifically turning that into a hub of sorts to advance these kind of technologies in an applied setting with intentionality around density of innovation. How do you see that future build out opportunity?
So ASU has 7 innovation campuses or sites, districts. The one on the Polytechnic campus is a fabulous site because it's very amenable to industrial scale engagement. And so we have several hundred acres there set aside in our innovation district on the Polytechnic campus. So yes, I mean, this is a place where these kinds of technologies can be developed, companies developing these technologies can be there. Student workforce is there, engineering specialists are there, the land is there, the systems are there, the infrastructure has been being contributed by the city of Mesa as it furthers its urbanization. So yes, that's a fantastic site.
Great, thank you. Well, we'll come back to you, Michael, as we get closer to the end of our event today with questions. So next, I'd like to introduce Bill Gross, the founder of Idea Lab. I've got to know Bill over the last few years as much like Michael on the visionary side of leading a learning institution. Certainly, Bill is extraordinarily well known globally as an inventor, a creator, early stage funder, certainly one that can scale enterprises. His track record is unmatched in terms of 150 company launches and almost half of those going public or having major exits. And so, Bill, I'd love to get your perspective. I know when we've spent time together, you've spent a lot of time thinking through climate and leveraging not only capital, but an inventive mind to address real world problems, and doing that with the intention of taking it to scale. So I'd love any perspective you'd love to share about not only your background, but certainly then how you view Arizona as this testing ground and scaling ground and future opportunity.
Well, thank you. It's an honor to be here. Dr. Crow, I am in awe of your vision that you shared and in awe of what you've accomplished in the last 20 years. And I think you've set the stage for this new revolution. I really think it is a big revolution, and I'll explain why and how we really can fulfill that dream and vision that you just shared. First, I would say, if you look back at what's happening in history right now, we've been through the Industrial Revolution, we've been through an amazing digital and computer revolution, but this new photon economy revolution is going to dwarf both of those, because, as you said, this is powering the entire planet. This is how all of the energy will be provided in the future. And we're basically building an entire new energy revolution around this. And we're building it in 10 or 20 years, what we've built over all of history up to now. And we're basically doing exactly as you said. If you think about the big sweeping path of human history, energy has been the lifeblood of civilization. At the beginning of civilization, we got all of our energy from biology. It was basically our muscles and animals' muscles that provided our power for the beginnings of agriculture and the agricultural revolution. But as you said, in the last couple hundred years, we went through a chemistry phase where we just burned everything in sight. We just burned things to get where we wanted to go. But for the future and for the rest of this century, it's really about physics. So we've moved from biology to chemistry and now to physics. And this new physics or new photon economy revolution is where all of the effort needs to go. You are cranking out all the talent that we need to do that. And we need a huge amount of talent. What's so exciting about this is we don't have to use just our muscles. We can use our brain power. It's using our brain power to solve these problems and then bring them to large scale. And I'll talk in a moment about how I feel that large scale can really emanate right from Arizona. Arizona has so many of things in place to make it be the central point. And I'll talk more about that. I'm so honored to be associated with you and with ASU and with Greater Phoenix. And I really feel, as I said, that Greater Phoenix and Arizona can be the epicenter of this revolution because of the resources it has, because of the talent, because of all the things, and because of the photons it has. You talk about a new photon economy. Well, there's almost nowhere else on Earth that has more photons striking down on the ground as Arizona does, as I know all of everyone who lives there feels. But we need to take advantage of that, both for the research and for the knowledge and for the learning so that we can export that. So I'll tell you about how my own story fits into that. My involvement in this revolution began when I started Idea Lab in 1996. I wanted to start a lab where we could prototype new ideas that could be turned into important companies to help society. And I modeled it a little bit after Edison Labs. Edison had a lab back in New Jersey where he would prototype ideas and take the best ones and spin them out into separate companies. So there was a separate company for the phonograph, and a separate company for the movie projector, and a separate company for the light bulb, which became GE. So I really wanted to try and make some place where we could prototype many ideas, but the best ones would get turned into companies. And that was the vision back then. And since then, we've had more than 5,000 ideas. Not all of them are worthy to turn into companies. But as Chris said, we turned 150 of them to companies. We've had more than 50 IPOs and acquisitions. And we have many, many companies that are still operating right now and growing that we hope can really, really make a big impact on society. When I look at the companies that we're choosing to do, we look for opportunities in the world, things that are big and broken, and brainstorm technology solutions. So there are many things in the world that are problems, but that technology can't address. But the ones that technology can address, as I said, the kind of students that ASU is producing that have the brain power to tackle technology problems, those are really, really great for scalability. And I feel that right now, humanity's biggest problem is to power the planet renewably, to make this a renewable system, not a system where we burn stuff where you only could burn it once, but a stasis that we can continue to power society in a very happy manner. And I really feel there's so much opportunity there. So over the last 20 years, I've started 20 different companies that all could have an impact on that. I try and find places where innovation can have some say or play in helping society become more sustainable. And these are the 20 companies that we built over that last period. I'll highlight just a few of them for you. Carbon capture, which you'll hear more about from Jonas in a moment, and this is to take CO2 out of the atmosphere. If you take CO2 out of the atmosphere, you can help us go back in time. So if you take a look at where we are right now on the Earth, when I was born, there were 330 parts per million of CO2 in the atmosphere. Well, today, right now, we just crossed 430 parts per million of CO2 in the atmosphere and growing about 7 parts per million every single year. So it's gone up a lot. And just in my lifetime, more than 25%. So if we can remove that CO2 that we made in the last 50 and 100 years, we could preserve an Earth for future humanity that was like the Earth that we inherited. So I think that's a very important thing to do. That will make a lot of the climate related things we're seeing right now, the horrific fires, the temperatures, the floods, the hurricanes, we can take those away if we can reduce that CO2 in the atmosphere. But we also can make Earth sustainable so everybody has the same chance that we got when we were gifted this planet. So CO2, you'll hear more from Jonas about carbon capture in a moment, but that's the mission of that company and many companies like that all have to work together because it's a big, big problem. We have to take a lot of CO2 out of the atmosphere to go back in time. Another company we started is called Flowing Energy. We want to convert waste heat to useful energy. If we can convert waste heat to useful energy, there's so much waste heat on planet Earth that we can take advantage of and make electricity or other useful energy out of it. And we really feel that's a big, big need. And again, a technological solution that we can invent something to do that. Water from air. You heard from Dr. Crow about solar water from air. We need to scale that up to such a degree. Water is going to become a resource that there are huge fights over. Water is becoming more and more scarce. We have plenty of water in the atmosphere. We have plenty of water in the ocean, but to make that water usable for humanity, we really need to capture it effectively. And there's lots of technology, lots of innovation we can do here. Again, brain power is the solution to this. It's physics, it's engineering, it's mechanical engineering, it's chemical engineering. It's all those things combined in very creative ways to make this more and more cost effective so all of humanity can have low cost access to clean water. Energy storage. Energy storage is such a big need. As we drive the price of making energy from solar and wind lower and lower, and now it costs less to make electrons from solar and wind than from fossil fuels. The only problem is not necessarily when we want it. Maybe we have lots of solar energy at noon, but right when everybody gets home at 5 p.m. and turns the air conditioners on from 5 to 10 p.m. after the sun has gone down, that's when we need lots and lots of energy. So we need energy storage to shift it from when it's made, renewable energy, to shift renewable energy from when it's made to when it's needed. So we have a company called Energy Vault that is working on gravity-based energy storage. And this really can help make energy storage scalable because we don't need any fancy materials to store the energy. We just need mass. So we can use dirt or gravel or rocks or waste material for the gravity-based energy storage. So it makes it very, very recyclable, very, very renewable, very, very clean, and very, very scalable. So Energy Vault, we're building systems that look like this. Imagine a building which you see in this picture here. It's 100 meters by 100 meters by 100 meters. So it's a 100-meter cube, 32 stories tall. And we lift up weights with elevators from the bottom 8 floors to the top 8 floors when the sun is shining or the wind is blowing. Then when you need energy, we lower those weights back down to the ground floors and get the energy back from generators that turn in the opposite direction. And we get that energy back very, very efficiently. It's a little bit like a dam where you pump water up and let water flow down, except we're not using water. We don't have to make a dam. We don't have to kill off any wildlife. We're just lifting weight inside of a building. So we're building these buildings all over. We're building this one in China that you see right here. We're building one in Texas. We're building one in Greece. We're building one in Egypt. These buildings store 100 megawatt hours of energy. Of course, we want to build this in Phoenix too. We want to build it all over Arizona. This technology can store a huge amount of energy so that a city can have reliable power, even if there's a grid outage, even if there's a power shortage, even if fossil fuel prices go up, and even if there's volatility, intermittency, which renewable energy has. So Energy Vault is a really great, exciting technology for energy storage. And there's a new company we've started recently that we're really excited about building out in Arizona. In fact, first, and we're already looking at sites to do this. And this is a company called Continuum Renewables. And at Continuum Renewables, we're taking the Energy Vault idea in partnership with them, and we're lifting weights up the side of a hill. If you have a hill, you can lift the weights up the side of a hill without even needing that expensive building. And that stores energy really, really cost effectively. So Arizona has a huge amount of great locations for this, what we're calling gravity battery slope. It's lifting weight up a slope to store energy. Here are some of the locations we identified all over Arizona, unbelievable heights that we can lift weights up to store energy extremely cost effectively. And effectively what you would do is lift weights from a valley down here up and put them up on top of a cliff here, and then lower them back down when you need the energy. And there's so many great locations throughout the state of Arizona. We're talking to the utilities already about doing this. And basically, with the combination of height and sun, Arizona is probably the best solar energy storage location in the entire world. Because look at the sunshine that is there and the hills that are there, make it really, really ideal. So we want to both invent, perfect, scale, and export that technology, showing it off in Arizona first and having everybody else in the world scale and copy that from all the learnings that we have from doing it right there in Arizona. So that's why we're so excited about that. So if you look at the 20 companies that I started in the last 20 years, I hope to start 20 more in the next 20 in partnership with Arizona. But if you look at each of these companies, they all have a huge connection and possibility with Arizona. We need to deploy them in Arizona at scale, just for Arizonans. We need to manufacture them in Arizona. Arizona is also a great place for all of these factories to be built. All of these things need to be scaled at an enormous scale. The energy business is so large. It's terawatts per year. All of planet Earth uses 15 terawatts per year, terawatts continuously all year long. So think about how much we need to remake and what scale we can have manufacturing in Arizona to bring that to the world. And we need to export it. So not only do we need to build it in Arizona for Arizona, which is so great because the hills are there and the sun is there, we need to teach the whole world how to do it. And that's why I feel Arizona can be such a great epicenter for this. When I look back on the last 27 years of Idea Lab and figure out what are the biggest lessons that I've learned and what's the most valuable thing that I wish someone had told me before I started Idea Lab, I put together those lessons. I have them at the Idea Lab website, so don't worry about reading them on the screen right here. But I'm going to call out 2 of them because they apply so much to exactly what we're talking about here today. The first is challenge the status quo. When you want to do something new and bold, exactly like what Dr. Crow was talking about, you have to really, really push for it because at first, sometimes it's ridiculed. Soon it becomes violently opposed because people start feeling threatened by it. But third, it's accepted as self-evident. And that's basically straight from this quote by Arthur Schopenhauer, great 19th century German philosopher. And I found this to happen so many times that if you want to do something really, really bold, you have to really push through. But when you make something that is first ridiculed and second opposed, and you make it be self-evident, eventually you've really changed the world and made the world a better place because you caused something to happen that wouldn't have happened otherwise. And I love the bold challenge the status quo vision that you've heard here today, both from Arizona State University, from Dr. Crow, and from everything that Chris and everybody, everything that is being talked about here. Arizona really is the leader in challenging the status quo. And then second, find great timing. If I look back on all the ideas that we've done over the years, not all of them have succeeded. I've learned a lot of lessons from the things that have not succeeded, but I found that timing most counts for success. The world has to be ready for what you're offering. You can't push something on people who don't want to accept it. And think about what's happening in the world right now, about how badly the world not only accepts, but wants this exact technology we're talking about. The Inflation Reduction Act that was passed last year is causing a huge amount of funding flowing through and a huge amount of pull, a huge amount of new manufacturing coming to the US, a huge amount of new companies investing and wanting renewable energy, companies wanting to reduce their carbon footprint. The timing could never be better. So the combination of challenging the status quo and great timing, the two biggest lessons I've learned, that exactly applies here. And that's why I'm so excited about this. To summarize, the timing is perfect. It's the best time in history for climate innovation. The money's available. The demand is off the charts. The whole world is reachable. So whatever we make right in Arizona, everybody's going to want. And almost every single part of the energy business it can be disrupted. The world cares about it. Of course, I told you I care about it, but the world cares about it. Maybe that matters even more. And I'm really, really excited to be sharing this with you. And I'm really looking forward to the next 20 years of innovation together. And thank you so much for inviting me to this. And I'm glad I could share this with you. Thanks again, Chris.
Well, thank you, Bill. And thanks for those comments. We're all inspired by the work you've done in a number of sectors and this shift to the photon economy focus and the ramifications or effects for Arizona are so significant. And we look forward to working together going forward. So I'll hold it because there's a couple questions that came in. I would acknowledge that if you do have a question for Michael, for Bill, or Jonas, who I'm going to introduce here in a second, please drop those into the Q&A bar below, and I'll field those and repurpose them. So next, quickly, I'd like to introduce Jonas Lee. Jonas is a Harvard MBA and the Chief Commercial Officer for Carbon Capture Incorporated. I've got to spend a lot of time with Jonas as well over the last a few years, and what carbon capture is looking to solve, and Bill referenced some of this in his introduction, is really affecting the carbon environment and certainly looking at byproducts within the carbon collection model. And probably different, Bill, from some of your other ventures. This one has been not only scaling rapidly, but the capital has been pouring into this particular company. And I'm hoping Jonas will be able to talk a little bit about that. And at the same time, I know that there's still some opportunity for this company, not only in Arizona, but continuing to grow and be deployed across the country. So Jonas, can you give us a bit of a perspective of where carbon capture stands? And this is one example of these technologies that will have most significant transformational effect to our society, but also how you plan to do that and execute over the next few months.
You got it. Yeah, I'm the boots on the ground entrepreneur, and I want to thank you, but also Bill and Dr. Crow for giving me the definition of hard acts to follow. So I'll do my best, but if everyone can just lower their expectations a little bit. I'm going to be a bit crass also because I'm going to talk about just pure economic opportunity, which I think is really critical if we're going to solve some of these climate problems at planetary scale. It's got to make sense. People got to make money because we're going to need a lot of money. As much as we raised already, we're going to need more because we're decarbonizing the atmosphere, carbon capture, and that's a big challenge. So let's see if I can get my screen to share. You guys tell me if it's working. Can you see it? We're good. Okay. So I got 10 minutes. I'm going to run through some stuff. I know I'm probably going to raise more questions than I answer, but I'm around. So if anybody is particularly interested in what we're doing to remove carbon from the atmosphere, just let me know. But I thought it'd be good to just describe why we're doing what we're doing and why it's such a big deal. Basically, the IPCC, the international body that's bringing everybody together to make commitments to decarbonize around the world, has now said we need to remove about 5 to 10 billion tons of CO2 per year from the atmosphere by 2050, and then keep doing it after 2050. That is a huge deal. So if you look at the math, and figure around $100 to $200 a ton to remove that CO2, that is $1 trillion business. There are not too many times there is both an economic opportunity to build a new industry this size, but to do it and feel good about what you're doing because you're doing something good for the planet. And I think that I've been an entrepreneur for a long time. I mean, this is my mission. I feel like it's all been building up to this. So this is to set the context in terms of what specifically we do. We develop, so we make, design, make, and manufacture and deploy, which is important, direct air capture machines. So there's a little image of these container-sized machines being assembled in the field. This is just a rendering. We're in the process of putting together these machines right now. But they do one thing. They remove CO2 from the atmosphere. They don't remove CO2 from the smokestack. That's another kind of company's job. We go after very dilute, so 420 parts per. It's getting a little less dilute every year, but it's still pretty dilute, and that requires a different type of technology. Bill started the company back in 2019. I was on the founding team with him. I've stayed with the company as we've recruited and built a team to about 55 people now, and we've raised 43 million, which has allowed us to really progress the technology. And now we're getting into the phase of deploy. Just to give everybody a kind of Chris said I have to step back a little bit and not dive right into the technology details. So I'm going to do that right here. But basically, our machines filter the CO2 out using low carbon energy. It could be renewables most likely, but sometimes it could be things like nuclear in the future. That CO2 that we concentrate out of the air is then delivered either for storage into permanent geologic structures via something called Class 6 wells, which make sure basically that they're permanently stored, or we can use that CO2 to make other products, to utilize them for things like sustainable aviation fuel or carbon black for tires or low carbon concrete, but basically get it out of the atmosphere. You got to do something with it. So it lowers the ppm. The technology that we use, and again, this is the kind of area where I could spend 2 hours talking about, but at a high level, we built a very flexible modular technology platform, something we just got the patent on it 2 days ago, by the way. Modular open, Bill, you don't even know that, so that's probably news. Modular open systems architecture, which lets us build these modules out of reactors and standardized cartridges. But these modules, if you can see my cursor here, they're again about the size of a shipping container, which means we can do it offsite in factories, which means we can mass produce them, which means we can continue to iterate the technology, not just build one big plant every 5 years or so. So this is really important because a big part of this game here is getting the cost down as quickly as possible and as low as possible, so we can remove as much CO2 as possible. That's our kind of secret sauce, is this flexibility. It's not one shot on goal. What's important to know is that governments want DAC to scale. I think there was a mention of the Inflation Reduction Act. There's really two big government programs that help us. First is the Inflation Reduction Act, and as part of it, there's something called 45Q, which basically gives us $180 per ton of CO2 removed from the atmosphere and permanently stored somewhere. In addition, there was the bipartisan infrastructure law that was passed before that, which allocated $3.5 billion to fund 4 regional DAC hubs. This is non-dilutive equity financing, so these are big prizes. And last week we won multiple awards: one in Arizona through ASU, one in Wyoming, and a couple small ones in California and Illinois. There'll be multiple ones out there, and we're now in that game. We haven't won the $600 to $700 million per hub yet, but we're on that ladder now, and that's really important. In addition to the government wanting us to scale, companies want us to scale. So why do they want that? So what companies are doing is they want to buy carbon removal credits from DAC, from companies like us, so they can offset their unavoidable emissions. So if they fly somewhere, if they do things where they can't reduce it and get it out of the way, they want to offset it with what is considered the highest quality offset. They're trees. Trees are great. Nature-based offsets are great, but the highest quality thing out there is take it out of the atmosphere, measure it, weigh it, verify it, and put it underground. And that's what we're doing. We recently just closed some big deals with Microsoft and BCG. And in about 3 weeks, I'm hopeful to be able to announce some really large deals from other high-tech companies. Generally, they don't have smokestacks. So the only way they can remove it is not to stop what they're doing, but to work with companies like us to buy credits. So we remove it for them essentially, and then they pay us for that offset. Okay, I'm going to talk some numbers real quickly. I feel like I'm really rolling quickly, but I can always circle back with questions. All right, here's the money. Okay, let me explain this. This is worth a couple minutes. So as you can see, these are our projections for our cost versus our income. And this is sort of a bit stylized, not exactly this, but gives you the magnitude and basic direction of our operating profits over time. Because the subsidies we get from the government back on top of the carbon removal credits that companies pay us. So if Microsoft pays us $500 for a carbon removal credit, the government will give us another 180 on top of that. They they're not separate like one or the other. They stack on top of each other. So I put stub here. That's 180 from the government. The credit prices we're charging come down over time as our costs come down, but our costs come down more rapidly than the credit prices that we're charging. And this market for credit is, I think, is generally thought to be extremely quickly growing as companies get closer and closer to 2030. And that's because many of them have made public companies making public goals of being carbon neutral or net zero by 2030. Now, some have 2035, some industrial companies have 2040, but there is going to be, as we see it, a huge onrush of demand. That's already starting out by some of these forward-facing companies. And the margin we think we can get, which we will plow back into building out more scale. I mean, it's good to be profitable, but we're not looking to distribute a lot of funds. We're looking to actually build out scale so we can always be the lowest cost producer out there and have a big slice of this trillion-dollar business that's developing over the next 20 years. Okay, so Arizona, what are we doing in Arizona? So in collaboration with ASU, we're building out the first commercial DAC system in the US. It'll be a relatively small system. It's not megatons, it's thousands of tons. And we'll be using this CO2 to put into products like low carbon concrete, into sustainable aviation fuel. And we're thinking that, we're how do I put this? People are watching us. People are watching what we do, not just in the government, not just in our own industry, but in the clean tech industry in general. And I think it will be pretty big news. And I think it'd be part of helping to establish Greater Phoenix as a major hub in this new photon economy. We're hopeful that other companies recognize what we're recognizing in Phoenix in terms of not just that there's good energy here, actual energy, but there's also a business-friendly climate looking to get things done. And in fact, we're not looking just to deploy our first big systems here. We're also looking to put in our manufacturing plant here. So if you see on the left here, our local manufacturing, I think we've already down selected to 6 different sites right now and are looking to finalize that fairly shortly and start manufacturing. Okay, so beyond Greater Phoenix, I just have 2 more slides to go. How am I doing on time? Okay, all right. The other big one is that I think, as Dr. Crow mentioned, ASU was just selected for a DAC Hub Award. And so in addition to doing utilization work with the CO2, putting our CO2 that we capture from the atmosphere into concrete or into creating sustainable aviation fuels, this DOE DAC Hub is all about storage, very large megaton scale storage. And I think, as mentioned before, the recent award, which is, I don't know if you can see this little tiny type here, but it's about $12 million on another $12 million in cost share. That sets us up for about another $600 million in non-dilutive equity funding in about a year and a half. And we're really excited to work with ASU and our partners there, Carbon Collect, on making that happen. So I'm going to take one breath now and go to my last slide, which is, we are currently in the process of closing a financing round, and we would love to have investors in the Arizona area that can help us strategically. I think it's great to have ASU and some others that have already decided to help us out, but as many connections, as much strategic assistance as we get from people that have a vested interest by investing in us, we would really appreciate. And I think Jonathan Cohen is going to be introduced a little bit here a little bit on from now, but there's ways of contacting us if this is interesting to you, and we'd love to show you a lot more about what we're doing and see if it's interesting to you.
All right, thank you, Jonas. Yeah, appreciate that overview, and you covered 12 sides very efficiently, so appreciate that.
Yes.
As reference, Jonathan Cohen, who I believe is on today, I'll ask our team to put his email in the chat. In that, I believe you have a deal room set up for anyone interested on the line here. I think there's 350 plus people on the call here today. If there's anyone interested in learning more about this opportunity, feel free to reach out.
Glad you didn't tell me that.
To Jonathan.
Yeah, I'm glad you didn't tell me that until just now. I appreciate it, but I thought it was like 20, so I'm very happy to hear that.
Excellent. Well, I'll ask Michael to come back if he's still available for our last few minutes we have here today. I've got a few questions that came in, and first, and it kind of comes back, Michael, I think you touched on this, and Bill, maybe your perspective too. What are the 1 or 2 items that you believe need to be in place for Arizona to become a dominant player in this photon economy, this climate technology advancement? The federal money is naturally there. Dr. Crow talked a lot about the learning environment in the physical environment. Anything else you'd like to share that we should be thinking about to ensure we have a well-rounded ecosystem that would support the scaling of this particular sector?
So we're for the first time now winning, leading edge, cutting edge technology demonstration projects that are in the national interest. We've not done that in the past. Very much in Arizona, we're able to do that now. We've got the workforce education at the college level, the training level. We've got those components in place. We don't have a lot of companies like Idea Lab, so we need Idea Lab here, and we need other companies here. We need places for them to land and work, like our innovation parks and other things that we've got going on, where you can move quickly, make things happen, be connected to workforce. We need risk-taking capitalists to make some early investments in these technologies to help them to accelerate. Meaning, we need the comprehensive environment that exists in a few other places that don't have the and fantastic conditions for positive economic outcomes. That is, this place is still a wide open territory. We still have all kinds of things that we can do here that are harder to do in other parts of the country. And what we need then is we just need for people to realize that all of the ingredients in this new photon economy environment are here. We have all of the ingredients, probably for the first time in anything outside of, some areas of microelectronics or some areas of agriculture, some areas of bioscience. We're now in this area. We're ready to roll. We're a leading edge place in all things, including where we're located and the physical attributes of this place. So the physical attributes, the technological attributes, the human capital attributes, everything's present. We need a critical mass of startups, a critical mass of new investors, a critical mass of new technologies. That's what we need.
Thanks for that, Michael. Bill, maybe I'll ask you this question, and Jonas too. This you both might be able to tackle this one. One of the folks referenced that capturing carbon in America today with the specific provisions of IRA. How do you envision the credit system for those companies, those logos you referenced, being able to go out to the market and buy these carbon offsets? How do you envision that in practice? And how will there be credit brokers that enable that to occur?
Yeah, Bill, I think I got this one since I'm in the middle of some of these deals. Yeah, right now they're basically bilateral agreements. We're negotiating with individual companies at a fairly senior level. This is a big deal often for the CEOs and their C-suite. I think over time it starts to become more of a standardized market or commodity market as there's megatons of availability. But right now there's like less than 10,000 tons per year, like far less than 10,000 tons per year being developed. So, supply is the problem. We are the problem now. We got to solve it. I don't think it's necessarily a demand problem just yet.
I would add one thing. That's exactly correct, Jonas. I would add one thing on this whole carbon capture category, which is fossil fuels have never worried about their externalities, meaning you burn the fossil fuel and the carbon goes into the atmosphere, and we're basically using our thin, beautiful sliver of the atmosphere around the Earth as a landfill, a trash bin for that carbon. And if we can make carbon capture cost effective enough, then you can build in that cost in your use of fuel and or eliminate the problem in the first place. It's only because we're throwing the trash up into the sky with no cost that we got ourselves into this problem. So using technology to solve that cost problem is brilliant and will really fix things. And as Dr. Crow said, on the ground in Arizona right now, everything is there. The talent, the land, the space, and then Chris, with what you're doing, the welcoming of companies, everything about having space to build, sunshine to power it, like everything is there. So I feel that the next step is just scale, developing it, showing it off to the world, and getting the word out that this is the place, like this is where it should happen. And we're doing that. It will happen. It will be known as that epicenter soon enough.
Great. Well, we have a barrage of questions coming in now. So you've incited the audience here. I'll try to capture kind of two of these into one. There's been a lot of discussion with environmental and social governance, ESG, as it's better known, and with respect to kind of corporate giants globally. And it's become somewhat of a political, tribal focus for whatever reason out in the political airwaves today. Do you envision any threat to, I mean, has the train already been so far in motion that companies are committed and this thing's unstoppable going forward in these commitments to the environment? It's kind of a broad question, and I have a second part. Anybody want to tackle that one?
Well, I think that companies are not hesitating doing it. They are hesitating bragging about it until they've done it. So going around and trumpeting your ESG value before you prove it, that's passé. But there's no reduction in companies committed to actually making the difference, as Jonas is seeing. The company, like Microsoft, has made one of the most bold commitments of anybody. Microsoft has said, I want to remove all the CO2 from the atmosphere that my company emitted since I was founded. Since my company profited from those emissions, I need to negate those, and not just going forward, historically, going back to 1975. So that is a very, very strong commitment. And more companies are making commitments like that. They're just not calling it ESG. They're just doing what they feel is the right thing. So I feel that in the end, doing the right thing for the environment and for social justice is what companies will do. They're just not going to try and get credit for it until they've proven themselves.
And just being a little bit selfish, just talking about direct air capture and carbon capture, we are remarkably middle of the aisle, actually. Republicans and Democrats like what we're doing, except on the far fringes, I would say. There's always some element, but the vast majority of whatever bell curve that looks like likes what we're doing. In fact, most of the money that we're spending typically is going to be in sort of former, there's a lot of oil and gas people, a lot of energy transition people coming into our industry. There's a lot of money that's being spent in those kinds of states. So, sometimes it's just a matter of economic opportunity. They don't necessarily have to believe in the vision of decarbonizing the atmosphere. That's okay, as long as they're supportive. And the one thing that was carved out of the folks who are talking about was it like going back on the Inflation Reduction Act? The one thing that was carved out was 45Q, which was the thing that supports us because everybody wants that. So we're feeling, still have my fingers crossed, but feeling pretty safe from those kinds of crosswinds, I would say.
Thanks for that, Jonas. So, Michael, one question about the STEM workforce. There's been a lot of discussion about U.S. competing markets for producing STEM talent. We've evolved exponentially over the last decade in that regard. Question from the audience around the current state of STEM delivery, and then certainly how do you talk to your students about the opportunities in this sector going forward, with the job opportunities that probably several of which haven't been created yet? But I'm curious your perspective.
So first, we don't talk to them about these opportunities. They talk to us about these opportunities. Meaning they say, why can't we build a new economy? They say, so our School for Sustainability and the Built Environment Engineering, our overall colleges of engineering, our Polytechnic School, our business school, with the people that are in the business school that are thinking about the futures, the carbon capture accounting company, Persephone, which is led by ASU folks that has spun out. I mean, this is what people are thinking about, and they're not thinking about it just for the enhanced planetary management outcomes of our relationship. They're thinking about it because they want to make money also. They want to build a new economy also. They want to stop worrying about some of these things and at the same time build this new economy. So we're not seeing any issue there relative to STEM and STEM training. We had a few years ago, we had 6,000 engineering students. Now we have 30,000 engineering students. And the reason that we have that is that we changed everything. The culture of engineering, the way that our engineering is organized. We found ways to make calculus more palatable for students who are not naturally calculus gifted. And so we don't see any problems whatsoever, none. We've got over 60,000 STEM majors now. We're advancing on every dimension. I heard a report today. We have over 9,000 biology majors. And that's growing rapidly. And we have now people double majoring in English and biology. We have the hottest thing in the market, by the way, are English majors and history majors who can code, because it turns out they have very, very broad brains and very significant thinking tools between their ears, and then you match that with a little bit of coding, and then they can be creative and they can think through things and bring in all kinds of dynamics. And so I just think that labor is not going to be our constraint. We will have some labor issues relative to the training of people in the specialized construction of some things. We're seeing that in microelectronics, we're seeing that in semiconductors, but those are things that are addressable and doable also. So I think that we have a very, very productive workforce, a very trainable workforce, a very capable workforce, and I think we can compete with anyone.
Yeah, appreciate those thoughts. Well, let me shift to, I know we're hitting time here, shift to kind of final remarks. We've got one chance to talk to the 300 plus business folks around the world, and many I'm sure are in Phoenix tuning in today. What would you impart kind of final words of how do we build this? How do we execute? How do we ensure we stay on the right track? We're ambitious naturally, but creating this roadmap is going to be critically important that we stay on track. So Bill, I'm going to start with you, then I'll go to Jonas, then to Michael, and we'll wrap it up.
Well, we've got this incredible once in a lifetime Inflation Reduction Act, a 10-year plan to really, really change the energy transition. And I feel we just need to jump on it. Let's jump on it and make Arizona a leader in just even the next year. Let's show some incredible demonstrated projects on the ground that make people want to help us scale it, bring in all the capital that Dr. Crow is talking about, and really bring everybody into Arizona to see what we've done.
Great. Thank you for joining us today, Bill. Appreciate it. Jonas?
Yeah, I would say, keep it up. And what I mean by that is we, as a little company with a big mission, we end up punching above our weight, and we really appreciate that. So if we need to get a call with somebody that's more senior than we would normally get, if we need to get a favor and get some materials and push the head of the line, we're getting a lot of great oomph. Like we're getting people they're lifting us up, and I just hope people keep that up, because what we're trying to do is pretty hard. It's new. There's a lot of risk to it. There's a lot of things we haven't figured out. It's easy to go, well, that's hard to can't happen. But so far, so good. We keep running into barriers and running right through them. And it's largely because, not just because of our team, but we get help from the outside. So keep helping us. Thank you.
Yeah, I think, Chris, what I would add is that, it really is the case. You've got to, if you're in business, or if you're an investor, or you're thinking about the future, or you're thinking about the success of Arizona, or the success of the United States, or the success of our relationship with the planetary systems on which we're dependent. The technology is there. It's all there. It's sitting there. What we have is I think, what was it? An Occidental oil company yesterday bought a carbon capture technology for over $1 billion. You got to get out of your old brain. The energy companies are going to become unbelievable carbon companies. They're going to become unbelievable photon companies. They're energy companies. They're not oil companies. And so they just happen to have oil as the easy, cheap thing that they can produce and distribute now. And so a whole new wave. I mean, basically, I don't know, 150 years of reliance on petroleum, and 400 years of reliance on coal. A lot in the last 200 years. Great. We got to where we are now. We know that we can't keep moving in that same direction at the same rate. We need these new ways to do things. Everything's there. Everyone's moving in this direction, and Arizona is perfectly positioned to be a mega center for carbon capture and unbelievable new clean energy systems and algae-driven energy systems and everything you can imagine. This is the place, and so people, I hope people are paying attention to what's going on. I hope they're paying attention. What's the biggest renewable energy state in the United States? Who knows? I know it's not California, it's Texas. And so the transformation is well underway. Now we're talking about making carbon, which is plentifully available in the atmosphere, more than we'd like to be there. Let's take it out of the atmosphere. Let's give it a value. Let's build an economy around it. Let's build industries around that. Let's make all these things happen. And it's like, I mean, literally, I mean, it's things are moving so fast that a lot of people are just, they're still watching, I don't know, maybe they're watching like Happy Days or something on television. They haven't realized that things have progressed, and these opportunities are really unbelievable.
I think you've just laid down the gauntlet for us to make Arizona the #1 renewable energy state over Texas. Let's make that happen for sure.
One would hope.
Yep, let's do it.
Well, thanks to all of you for joining us today, and the guests certainly for attending. I can tell you these three leaders are setting a trajectory that I don't believe Arizona's ever felt the opportunity that we're feeling today. And talking with the governor, our senators, our legislature, our business and civic leaders, what an incredible chance for us to be great, globally great. And so as an economic leader, you almost you wish for this to happen at a time in your career where you can build something that hasn't existed around a talent disposition that we're continuing to strengthen. And at the same time, the evolution of our capital ecosystem will play an absolutely pivotal and critical role in seeing this happen here. And then, as Bill said, our goal is to invent, scale, and export to the world these novel concepts. So with that, if you have additional questions, feel free to reach out to me. I believe we did drop Jonathan's email in the chat. Feel free to reach out to him. And again, thank you again, Michael, Jonas, and Bill for joining us today. And have a great rest of your evening. Take care.
Thank you. Thanks for having us.